So if negative 4 cosine theta plus 3 equals 3, we're supposed to solve all the values of x. So let's start with this. Negative 4 cosine theta equals 0. Right? I just subtracted 3 from both sides. And then if you divide both sides by negative 4, I'm solving it just like a normal algebra equation. Really, we're just trying to figure out where cosine equals 0. Cosine are the x-coordinates on the unit circle. So here the x-coordinate is 0, and here the x-coordinate is 0. So theta in terms of pi, so we need it in radians. That's pi over 2. And then our other solution is 3 pi over 2. That's all the solutions in one full revolution of the circle. To type that in, I'm going to type, oh no, I can't type pi. I got to click pi over 2. And then it says to put a comma. So just make sure to arrow out, then put your comma, and then put 3 pi over 2. Oh man, no, this is, I was hoping to have a different question. Let me get this one wrong. Wait, I don't know what the right answer. Okay, so let me get this one wrong. Let me pull up a different one. No, this is also going to be, a lot of the ones I'm getting are 0. I want to do a different one. Yeah. That's going to be 1. We don't want to do that one, because if cosine theta equals 1, then theta needs to be 0 or pi. Not even pi, though. Pi would be negative 1. So those ones I'm looking for. This is a good one. Let me do this one. Okay, sorry about that. Because the other cosine one I did was for a special angle. So to solve this equation, we want to get cosine by itself. So subtract 7 from both sides. And then divide both sides by negative 4. So you're going to get, when you divide both sides by negative 4, you get square root of 3 over 2. And so we need to evaluate where theta equals square root of 3 over 2 for cosine. So think about, it's a positive square root of 3 over 2. So think about where cosine is positive. They're all positive in the first quadrant, and cosine is positive in the last quadrant here, the fourth quadrant. So that's where our triangles need to be drawn. And cosine needs to have the adjacent over the hypotenuse be square root of 3 over 2. So if we draw this in the unit circle, 1 is the hypotenuse. That means the adjacent has to be square root of 3 over 2. Okay? And in order to make that happen, 60 degrees is supposed to be opposite of square root of 3 over 2, right? With our special triangles that we memorize. 30 is always opposite of 1/2, and 60 is always the angle that corresponds to square root of 3 over 2 if we draw it in the unit circle. So that means that this needs to be 60. That way the adjacent over the hypotenuse is square root of 3 over 2. So that makes this angle 30 degrees. This is 30 degrees, which in other words is pi over 6. And then to make a full revolution, that's 2 pi. So that 11 pi over 6 would also make the 330 degrees it takes to rotate around here. Looks like this one here.